The last type of variation that we're going to talk about is joint or combined variation. And this happens when you have more than one input variable. So previously, when we had y directly proportional to x, we had y is equal to just k times x, and there was only one input variable, the x, where k was the proportionality constant. But this time we've got y varies jointly as x and z. And so in this situation, there are two input variables, both x and z, and k, again, is a constant. It's also possible to have an equation where the proportionality constant k isn't necessarily multiplied by the input variables, but can be divided by one or more of them. So in this case, we've got y varies directly as x, so k is multiplied by x, but we also have that y varies inversely as the square of z, and so that inversely indicates that the z is in the denominator and then also squared. We can express this same equation as y is directly proportional to x, again having the k multiplied by x, and inversely proportional to z squared. Now let's take a look at an example that involves joint variation. So we've got drag force on a boat, F, varies jointly as the wet surface area, A, and the square of velocity, V. So let's start off by translating this equation. We've got F varies jointly, so whenever I see the word varies, I'm going to start with the F. And varies, I will translate into equals K, so that proportionality constant will either multiply or be divided by the input variable. So now it says it varies jointly, but it doesn't say directly or inversely, and the implication is that whenever neither the words direct nor proportional is used, we will assume it to be direct. So it varies jointly, but it means directly as the first variable, A, and also as the second variable, the square of velocity, so we'll take the V and square it. And then the only instructions we're giving is to write a generic equation containing these quantities, and we have done that. We have shown the relationship between F, the output variable, and the input variables A and V squared. Let's take a look at one more example. So we've got body mass index, represented by the variable B, varies directly, and I'm just going to start translating that equation. So I've got, again, B, the body mass index, varies means equals some proportionality constant, either multiplied or divided by another variable. In this case, directly as weight, so that will be represented as multiplied by W, and inversely as the square of height, so that means we will be dividing by h squared. And the first part asks if B is equal to 23.0, so we'll plug that in. B is 23.0. When h is equal to 70 inches, so h is squared, and we will square this as well, and w is equal to 160 pounds. So from our equation, we still have the proportionality constant k, which we don't know yet, but the weight, again, is 160. So when we simplify this, we end up on the left-hand side, we still have 23 is equal to k times 160 divided by 4,900. And there's not a lot here that can be simplified. I can divide numerator and denominator by 10, but when I solve for k, I've got that it's equal to 23, and then I'm going to multiply by the reciprocal here, so I want to be dividing by 16 and multiplying by this 490 that remains. So when you work out all of those figures, you end up with k is equal to about 704. And that is the proportionality constant. And so we are told to write a formula for B. So we started off with our generic equation, which basically has all the relationships intact, and the only thing that we're needing is to find that value of k and put it back into the equation. So now I'll do that, and I've got that B is equal to, and then again the value of k is 704, times W, but divided by h squared. So this is my specific equation. It can be used to calculate the BMI for any given height and weight combinations that are given to us. The second part of the question says, what is the BMI of a 60-inch, 100-pound girl? And this is where we're given that information. We use the weight, which is given 100 pounds, divided by the height squared, height being 60 inches, and we can again perform that calculation. So we've got that B is equal to 704 times, again, W, which is 100, divided by 60 squared. And this is something you can do on your calculator, but when we grind out all the details, it comes out to be about 19.5. So this is a person who is in the healthy range, healthy usually being between 18 and 25, and a little bit on the low side, so she's a kind of slender person.